Today we're going to talk about product and quotient rules with our exponents. So there's this kind of crazy acronym we use for trying to remember some of these rules called MAD SPAM. If you don't remember SPAM, it's a canned meat back from the old days. So MAD SPAM, this is going to help us remember some of these rules. So here's the first one. M stands for multiply, and it has to be with the same base. So I have to have the same base, but when I'm multiplying them, what I'm going to do is add the exponents. So M stands for multiplying with the same base. If that is true, then I add the exponents. Next comes division. When we divide, again with the same base, this time we subtract the exponents. And lastly, we have what we call power of a power. So P, or the PA, stands for power of another power. This is basically when we have the same base, and again, this is referring here back to the same base, with an exponent being raised to another exponent. This time, we multiply our exponents to get our answers. So let's kind of take a few examples and see what they look like. So for this first one, 2 to the 4th times 2 to the 5th. So what I'm going to do here on this first one is I'm going to kind of draw it all the way out for you. So if I look at this one, really 2 to the 4th is 2 times 2 times 2 times 2. There's 4 2's that are being multiplied together. Then 2 to the 5th is another 2 times 2 times 2 times 2 times 2. So if you just kind of expanded all of them out so that there were no exponents, and I just went through now and counted 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 2's being multiplied together. So really, 9 2's multiplied together makes 2 to the 9th. But the shortcut, without having to do that every single time, is that if I look back up into MAD SPAM, we are multiplying same bases, in this case 2's, it's a 2 base. This MAD SPAM says just add the exponents. So when I look at this, to be quicker, is I would say it's 2, and then really just thinking of it as add the 4 and the 5 together to go right to 2 to the 9th. Now notice this just says write my answer using exponents. Doesn't say tell me what 2 to the 9th is. It just says write it with exponents. So 2 raised to the 9th. So looking at the next one, we have a negative 5 times a negative 5 to the 6th. Now remember, we talked about these parentheses. The negative 5 is only the base right now on the second one. So remember, negative 5 being the base, you have to have parentheses. So I can change negative 5 to just add parentheses because it's not really going to add anything to this in this case. And if you think about it, there's only one negative 5 there. So even though there's no exponent there, that really means that there is one sitting there. So if I'm using my MAD SPAM rule, so the MAD SPAM says multiplying same bases. So I didn't have same bases, but now I do by putting it inside negative 5. All I have to do is add the exponents, which means I would keep the base as a negative 5, and now I just say 1 plus 6, it's negative 5 to the 7th. Moving on to the next one. So we do have the same base, x to the 3rd times x to the 7th. Again, has to be the same base. If it's the same base, I can bring down that base. MAD SPAM up here says if you're multiplying same bases, add the exponents, which means I would just say take the 3, add the 7, so this is x to the 10th. And that's it for now. I know we don't know what x is, but that's okay. We can simplify that to at least x to the 10th for now. Then we get to the division one. So notice this time we see 2 base again, This time, this fraction bar means to divide. So if I look up here, divide with the same bases says to subtract the exponents. So again, I think I'll just draw it off to the side so you can see it. I'm going to bring it way over to the side over here for the moment. If I was to do 2 to the 6, that means 2 times 2 times 2 times 2 times 2, 6 times, divided by 2 to the 4th. There are 4 2's being multiplied. Now let's think about this. When we reduce fractions, we do this all the time. If I have the same factor in both the numerator and the denominator, those would cancel and become 1's. 2 divided by 2, 2 divided by 2, 2 divided by 2, 2 divided by 2. That leaves me with 2 2's left over, which would be 4, but just leaving it the way of the exponent, we would have 2 left over. And that's no different here, but I can do it faster if I use my exponent rule. So let's come back over to the D, base of a 2. The MAD-SPAN rule says subtract them, 6 minus the 4, and there's that same 2. We can do it faster than trying to write them all the way out. This obviously would make a bigger difference if this was 2 to the 60th over 2 to the 45th. I don't want to write all those out. Just use the MAD-SPAN rule. Okay, letter E, the next one. We do have the same base. So again, same base. Dividing tells me subtract. So when I come back to this, my same base, and I definitely want to keep it in the parentheses because that'll make a difference. And I'm going to do 9 minus 3, or negative 7 to the 6th power. Okay, and the same idea here with the last one. So H, without doing all this out. 9, F is H to the 7th over H to the 6th. So same base. 7 minus 6 is H to the 1st. Or, in this case, we don't usually write H to the 1st, we just write H. Because it's saying using it with exponents, maybe you write it, but maybe you don't. H is still the same thing as H to the 1st. Now, moving on, this last one here, this last row, is talking about, we see one base, the base of a 3. This 3 is being raised to the 4th, but then it's being raised to the 3rd. So that one refers over here to a power, the 3 to the 4th, being raised to another power. Again, one base being raised to 2 different powers. And what it tells us to do here is to multiply. So again, just like we did in those upper ones, I'll expand this out just so we can see how this one works. So this really looks like 3 times 3 times 3 times 3. That's inside the parentheses. But the outside of the parentheses says that there are 3 of those. There's the second one. And there's the third one. So now, once I've expanded out 3 to the 4th 3 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would tell me the answer is 3 to the 12th. The easier rule is to remember this power of a power. You include the base. You would be multiplying 4 times 3 this time instead of adding, and you would get 3 to the 12th. But that thing below explains why that is. I'm starting to run out of room here, so it's going to get a little challenging, but we'll sneak this one in here. So the next one, w to the 5th raised to the 4th power. So again, w to the 5th to the 4th power would look like this, power of another power. The key is there's one base that we see. It's not really the same base in this case, it's just one base. So we would see that there's a w as my base being raised to 2 powers. So the w is going to stay. And this time I'm going to say 5 times 4 is my new exponent. So it is w to the 20th. Okay, and lastly we have b to the 12th raised to the power of a 3. So again, if I'm doing the base is my b, we'll change it to green to stand out a little bit. And then this time, 12 times 3 is my answer. I don't need to write out all of those. I get 12 times 3 is b to the 36th. And there's my answer for I. So next is a few that I want you to try. There's about 9 of them here. There are 9 of them here. So give them a shot. You can pause the video, run through all those, come back on, and we'll see how we all did. I'm just going to show you the answers. We'll touch on a few of them as we go, but then we want to get into the next one. So how'd you do? Here are the answers. There's a couple of quick things that I just want to touch on as you see these. I think the letter A is pretty easy. You're just doing the multiplying, so you add the exponents to get 6 to the 6. On any of these fraction ones that you see secondly, even though there is a negative in there, you definitely want to include the parentheses. I think mostly in general, you want to include parentheses around your fractions always, so there isn't any confusion that your numerator is getting the exponent but not the denominator. I think it's a good habit to have all of your fractions or your negatives, definitely, if that's your base, inside the parentheses. And then C over here, very important on this one. A lot of times we get this answer as just z to the 12th. But remember, there is a 1 there. We just don't usually show it. But that is really z to the 13th. Down here, pretty basic on this one. This one, again, you could have had 4.1 raised to the first power or 4.2. This last one definitely needs to have a parenthesis. So remember, our base is a negative 8. If you just put negative 8 without the parentheses to the fourth, that answer is different. It would be a negative answer. Whereas this answer with 4 negatives will be a positive answer. So it's important on your negative bases or on your fractions to definitely have your parentheses around. Now, in the last row, again, this is the power of a power. You see 1 base and 2 exponents. You multiply those to get your answers. And again, on letter I, you can see why you need those parentheses. That would be a positive answer. If you didn't have the parentheses, it would turn into a negative answer. There is another rule that we want to talk about called the power of a product. So power of a product, if you think about the power is the exponents, product we know means multiply. So here's an example of a number, and you don't really use this very often with numbers, because if I gave you an example, 4 times 2 raised to the second, it'd be very easy to say, well, order of operations says make those 2 times 4 is 8, 8 squared is 64. This just is kind of showing you 2 different bases on the inside, how each the 4 and the 2 are both going to get raised to the second power. So just showing you the steps with numbers, this is one way to do this, but I really want to focus more on this algebra part. So here's an example, 3xy raised to the second. So what we can see, unlike in the MADSPAM rules when they had the same bases, we can see 3 different bases inside here. We see a 3, we see an x, and we see a y. We can see that these are all being multiplied together, which is the power of a product. So here's the product on the inside, the power, the 2 is on the outside. So the way this would expand would be for the next step to be 3 squared, so the 3 gets the 2, x gets the 2, and y gets the 2. All 3 bases are raised to the second power if it's on the inside of the parentheses. Okay? And the only other step that maybe you might ask here is, if you were trying to solve this, you could still do 3 squared to make this 9x squared y squared. But this is basically how the power of a product works. When you have different bases on the inside of parentheses that are being multiplied, and they're being raised to an outside power. So let's try a few. So here's the first example, 2x raised to the third. So we definitely have 2 different bases. We have a 2 base, and we have an x base. So the 2 is going to get the 3 on the outside. The x is also going to get the 3 on the outside. And if this just said, leave your answer as exponents, this would be all you would have to do is 2 to the third, x to the third. If they wanted you to simplify it more, you can do 2 to the third, which is 2 times 2 times 2, or x to the third. The next one, very similar. We just did this one up above, so I don't need to do that one out again. But basically 3 different bases. The 3 gets the 2, x gets the 2, and the y gets the 2. Now, because those are all the same bases, different bases, don't make the mistake of saying add those together. You do not add them together if they are not in the same base. On this last one, I also want to just show you, I have more space on this one, so I wanted to show you this too. So I did show you how these all expanded out. So let's think about 5y to the fourth. Looks like 5y times 5y times 5y times 5y. That's what 5 to the fourth would look like. So that kind of shows you where these 4 5's come and where these 4 y's come in. So to look at the rule, we're basically saying each base gets the outside exponent. Oh, that's pretty messy. So the 5 will get the 4, but so won't the y. It gets the 4. But over here you can see where that's coming from. That's where these are coming from. The 5 to the fourth, and the y's, there are 4 of them, and that's where this can kind of come into play. On the next one, I would then go to ab to the fifth. So there are 5 of the a's, there are 5 of the b's. That's as far as I can go. And on letter E, there are 3 different bases. Each of them is going to be squared, so 0.5 raised to the second, m to the second, n to the second. And that's power of a product. So these next examples, so what we're looking at here is now simplifying with several of them working together. And there's more than one way that you can do these. So in this first one, simplify 3 to the fourth times 3 to the second and then divide it by 3 to the third. Well, I'm going to use my mad spam rules here first to look at my numerator. If I focus on the numerator, I can see same base being multiplied, which tells me to add the exponents. So the numerator, if I go step by step, is now going to be 3 to the sixth over 3 to the third. Well, in my mad spam rules, same bases, when we divide, it tells me to subtract these two exponents. So I'm going to say keep that base of a 3, and then 6 minus 3 gives me 3 to the third. Moving on to the next one. So again, you can do this in different ways. I could simplify each fraction first and then multiply. I'm just going to multiply straight across. If I look across the top, I see -4 times another -4 with these two exponents, which means in mad spam, when I multiply same bases, I add the exponents. So my new numerator is going to be -4 to the 17th. When I go across the bottom in the denominator, -4 times another -4, I add these exponents just like we did in the numerator. So now I have -4 to the 7th. And again, in mad spam, we would say when we're dividing same bases, we keep the base, so the -4 stays in parentheses. This time we subtract our exponents. 17 minus 10 is 7. 17 minus 7 is 10, and there's your -4 to the 10th power. And then lastly, we have an a base. So I'm just going to follow the same path. I keep the a's, add the exponents across the top to get a to the 16th. A's, add the exponents across the bottom to get to the 10th. And then when I divide, I keep the a. 16 minus 10 is 6, so a to the 6th. So this next one's a little bit tricky. So we're looking at how 1 gigabyte of computer storage is really 2 to the 30th bytes. Right, that's the information we're given there. The details of a computer are shown below in this little chart. So the total space is 64 gigabytes. How many bytes, so that's what we're trying to answer, of total storage does the computer have? So when I look at these numbers down here, these numbers are not matching. I have 64, 16, and 2's. So to use my mad spam rules, I have to have the same base. So let's look at how I can look at these numbers down here. So the number 64 under my total space, I need a base of 2, so I'm going to try 2's. 2 times 2 is 4. So that's obviously not 64. Times another 2 is now 8. Times another 2 is now 16. Times another 2 is now 32. Times another 2 is now 64. So that's telling me that 64 is 2 to the 6th power because there were 6 2's that got it there. So once I know that the total space in our computer is actually 2 to the 6th gigabytes, now I can start to figure out, well, what does that tell me for how many bytes there are? So basically, now I have these numbers in the same bases. I can say I have this many gigabytes, and every one of them has this many bytes. If I multiply those two together, I would know how many bytes I have in total. So again, with our mad spam rules, we have the same bases of 2's, which tells me when I'm multiplying same bases, I add the exponents. So it's going to be 2 to the 36 bytes on this computer. And then the last one, so we have the projected population of Tennessee in the year 2030 is about 5 times 5.9 to the 8th. We want to predict the number of people per square mile. And we're given this model here to help solve this for us. So the people per square mile, well, that's what we're trying to find. So I don't need to fill that in. This piece right here, that's what we need to know. So do we have the population? Well, we do have the population right up top. So the population, I'm just going to fill in as 5 times 5.9 to the 8th. That's my numerator. Then it says, do we know the land area? Well, the land area is right about here, is 5.9 to the 6th square miles. Well, I can simplify this right here. We have the 5, really can't do anything at the moment, but 5.9 times 5 divided by another 5.9, right here is a mad spam rule. When I have same bases and I'm dividing, I subtract my exponents. So if I take 5.9 to the 8th, 5.9 to the 6th, and divide them, I get 5.9 squared. And as I'm not concerned right now with what this is going to look like as far as a number, we're just going to leave this as predicting the average people per square mile. We're going to say population per square mile. I'm not really concerned right now what that actual number is. It's more important that we understand how we can use the exponent rules to get there. Hopefully that helps. If not, please make sure you are checking in and asking questions in class.